Hi everyone. In this module, we're going to spend some time discussing the basic principles of exercise training and then transition to our discussion of common measures of athletic performance. Now, athleticism incorporates many physical abilities, some of which are more amenable to training than others. Such abilities may be called components of athletic performance, which is the ability to respond effectively to the various physical demands of the specific sport or event. Now, the strength and conditioning professional who has a broad understanding of the principles of exercise training and common measures of athletic performance can effectively choose and implement tests and measurements to make training program decisions that help athletes not only optimize their physical preparation, but also to maximize their potential. Now, to do this effectively, the strength and conditioning professional must administer tests correctly, analyze test data accurately, and then combine the results of selected tests to generate what is known as an athletic profile. Let's first start our discussion of the principles of exercise training. Now, to optimize the exercise program and to set realistic training goals, the principles of exercise training need to be understood. These training principles are the basic tenets of exercise science and are valid whether one is designing a resistance training program or an endurance training program. So the first principle is the principle of individuality. This simply states that each person responds uniquely to the stimulus of exercise training. This is where we get the terms that we commonly hear of high versus low responders. Based upon this principle of individuality, we must design training programs taking into account the specific needs and abilities of the individuals for whom that training program is designed for. Later on, in a separate module, we'll discuss we'll perform a needs analysis on different athletes and individuals, and again, taking into specific needs and abilities of that athlete in order to generate a specific training program. The next principle many of us have heard of is the principle of progressive overload. It states that for an adaptation to occur, an organ system or tissue, such as muscle tissue, must be exercised at a level beyond which it is normally accustomed. So, thinking back a little bit, what are some variables that we can manipulate in order to overload the body? Now, if we think specifically about resistance exercise training, we've talked much in detail about the acute program variables. Go back and review those, but we can easily manipulate the acute program variables within the context of a single bout of resistance exercise in order to influence the overall training response. Other things that we can manipulate in terms of the training program itself, including the frequency, so the days per week of training, the intensity at which training is performed at, the time devoted to each training bout, and the type of training. We know that the adaptations to aerobic training are much different from the adaptations following resistance training. The key here with progressive overload is that there's a systematic and gradual progression that allows for these physiological adaptations to occur, resulting in improved function over time. Now, if we do not follow the principle of progressive overload and try to do too much too soon, something like this may happen, where you're trying to lift too heavy of a weight, your muscles are not accustomed to that heavy load, that heavy stimulus, and you end up failing on a rep. So some simple examples to apply this principle of progressive overload. So in terms of resistance exercise, we can either increase the resistance or load that is used for a given exercise. We can increase the reps, we can increase the sets, or a combination of any of those three in order to stimulate further gains in muscular strength. Now, with aerobic exercise training, we can increase the duration, we can increase the intensity, and so on, in order to induce specific adaptations. Another very common principle of exercise training is the principle of specificity. And it states that training adaptations are specific to the type of exercise performed, the volume as well as the intensity of exercise, the muscles involved in the activity, also the fiber types that are recruited during that specific exercise activity, and also the speed at which the exercise is performed. So here's a cartoon illustrating the principle of specificity, and again highlighting that you must do specific exercises to improve specific components of physical fitness and specific body parts. So here this guy with a large amount of muscle mass performs primarily resistance training, is concerned that he has low cardiovascular fitness. So if he was indeed interested in improving his cardiovascular fitness, then he would need to include some aerobic exercise training in his existing training program. So some of you may have heard of the SAID principle. And what that stands for is specific adaptation to imposed demands. And this simply states that the type of demand placed on the body dictates the type of adaptation that will occur. That's just another way of saying that the specific adaptations are specific to the exercises that are performed. So we talked a little bit in the last module about some of these physiological adaptations. So with endurance exercise training, primary adaptations, particularly within skeletal muscle, are increases in skeletal muscle number and density, as well as an increase in capillary density, which overall increases the muscle's capacity to produce energy aerobically or with the use of oxygen. With resistance training, the primary adaptation we see within skeletal muscles is an increase in protein synthesis over time, leading to an increase in contractile proteins within skeletal muscle, a process that we call muscle hypertrophy. And overall, this leads to an increase in force development. Now, if we stop training, then the principle of reversibility comes into play, simply stating that training benefits are lost if training is either discontinued or reduced abruptly. So basically, if you don't use it, you lose it. So we have in this example here, in a person who is physically active, they have this amount of muscle mass. After a period of inactivity, whether it's because they become sedentary or maybe they become injured, either way, they're inactive now. And we see muscle atrophy occurring. We have loss of muscle tissue due to disuse. Because of this principle of reversibility, it's important to include a maintenance plan in an individual or athlete's overall training plan. A lot of times you may hear this maintenance plan referred to as an active rest period, or occurring during the athlete's post-season, following the last competition. This maintenance plan is important to include in the overall training program in that it helps to sustain the physiological adaptations that have been gained by prior training. So here's an example of the reversibility principle. Here we have increases in strength and power over the course of either 10 weeks of training, we see here in Group A, and then Group B, they only train for 4 weeks. The training does not matter here. In this case, the 10 weeks of resistance training, they resulted in this increase in the 1 RM strength, so about a 30% increase, whereas as expected with shorter durations of training, an increase but not to the same magnitude as the longer duration training program. But what we see here, basically the greater improvement achieved while training, the longer it takes to return to pre-training levels. So in Group A, they again trained for 10 weeks and then underwent various detraining methods. So they either stopped performing resistance training or completed complete bed rest, or they underwent what they called a maintenance training program. What we see is that inclusion of this maintenance training program greatly minimized losses in muscular strength during this detraining period. So again, highlighting the importance of including a maintenance training program or period in the athlete's overall or annual training program. Another very important principle of exercise training, particularly pertaining to resistance exercise training, but it can also apply to aerobic exercise training, is the principle of variation. Many other times you may hear this called periodization, and there'll be an entire module dedicated to periodization later this semester. So periodization is simply the systematic process of changing one or more variables in the training program over time in order to maximize the effectiveness of training. Another way of thinking about this, much more simple definition, is planned manipulation of the acute program variables. So, in terms of a single bout of resistance exercise, we have the 5 acute program variables. So, exercise selection or choice, exercise order, load. This is commonly also referred to as intensity or resistance. The training volume, which can be calculated as reps times sets. Another way of calculating training volume is load times reps times sets. And then the rest intervals between sets and between exercises. So what we know is that varying these acute program variables in the context of a single bout of exercise, not only does it help to prevent boredom of the athlete or individual, prevent staleness, and also has been shown very effective in preventing a condition known as overtraining. And this overtraining is marked by large decrements in overall performance. And that's something we'll come back to later on when we discuss periodization of training. All right, so let's turn our attention now to athletic performance. What is that? So we know that athleticism incorporates many physical abilities, some of which are more amenable or changeable to training than others. Such abilities may be called components of athletic performance, which is simply the ability to respond effectively to the various physical demands of the specific sport or event. So there are a number of components of athletic performance that are amenable to training. We're going to talk about each one of these individually in the next video, including maximal muscular strength, maximal muscular power, local muscular endurance, anaerobic capacity or power, aerobic capacity or power, and then finally a little bit about agility, speed, flexibility, balance and stability, as well as body composition. And for many of these components, we'll highlight specific tests that can be utilized or implemented to determine where maybe weaknesses and strengths exist within a specific athlete. And also for many of these tests, we'll look at age and sport-specific descriptive and normative data in order to compare athletes to other athletes who perform similar events or in similar sports.